Hello chemistry students, we are back. This is my chemistry kitchen and we're going to continue our lesson, Fun with Baking Soda. So take a look at your worksheet and it says let's decompose some sodium bicarbonate and make some sodium carbonate. So number 4 says that the equation says we need 2 moles of sodium bicarbonate. So let's mass out 2 moles of sodium bicarbonate. But remember, I don't have a scale in my kitchen that measures moles. I only have scales that measure in grams. So we need to figure out how much 2 moles of baking soda or sodium bicarbonate weighs. So here on my whiteboard, I have my equation. But in order to figure out how much 2 moles of sodium bicarbonate weighs, this is what we're going to do. So 2 moles of sodium bicarbonate is what I'm given. This is what I'm starting with. And I'm going to create a proportion using what I know about molar mass. I know that the molar mass of any compound is equal to 1 mole of that compound. And since I have moles of sodium bicarbonate here, this is what I'm starting with, I'm going to write 1 mole of sodium bicarbonate on the bottom of my proportion. 1 mole of sodium bicarbonate, like I said, is equal to the molar mass in grams. So let's figure out what the molar mass of sodium bicarbonate is. I have 1 sodium, which is 22.99 grams. I have 1 hydrogen, which is equal to 1.01 grams. I have 1 carbon, which is equal to 12.01 grams. And I have 3 oxygens, which is the same as saying 3 times 16, which is 48 grams. And first of all, I got all of these numbers from the squares on the periodic table. And if I add them all together, I get the mass of 1 mole of my compound, sodium bicarbonate. And when I add this all together, I get 84.01 grams. Great, I'm going to take this and put it up on top of my proportion. And remember that this means that 84.01 grams equals 1 mole. And now I get to cross out my units, moles of sodium bicarbonate, because that's not what I'm looking for. I'm trying to figure out how much sodium bicarbonate I need to measure out in order to have 2 moles of sodium bicarbonate. So now I'm going to multiply 2 times 84.01, and I get 168.02 grams of sodium bicarbonate. So great. So in order to run this equation, all I have to do is measure out this many grams of sodium bicarbonate. But I can already tell that there is a problem. I already weighed out all of the sodium bicarbonate, all of the baking soda that I have. And look, let me bring you over here so I can show you. So here's my scale, and hold on a second, let me clear it. There we go. This is all the sodium bicarbonate, all that I have. All I have is 52 grams of sodium bicarbonate. So what this means is that I don't have enough to run this equation like it is. The amount of sodium bicarbonate that I have, 52 grams, is going to limit the amount of sodium carbonate that I can actually produce in my oven. So what we're going to do is calculate something called the theoretical yield. Let me put you back in my holder here. So the theoretical yield is determined by the limiting reactant. And in this case, we only have one reactant, but I don't have 2 moles of it. All I have are 50 grams. So if I have 50 grams, or I think it was 52 grams of sodium bicarbonate, I'm not going to be able to make a whole mole of sodium carbonate. I'm going to be making a little bit less. So let's see if we can't figure out how much sodium carbonate I'm going to be able to produce here. All right, so I don't have that much baking soda. I've only got 52 grams. So I've only got 52 grams of sodium bicarbonate. So what I want to do is figure out how much sodium carbonate can I produce with just 52 grams of this. So what I'm going to do first then is create my first proportion. And since I'm starting out with grams, that means that I need to put grams of sodium bicarbonate on the bottom and put 1 mole of sodium bicarbonate on the top. What number do I put here next to grams? Well, this would be the molar mass of sodium bicarbonate. And once again, the molar mass of sodium bicarbonate is 84.01 grams per mole. All right, so now I would be able to cross out grams of sodium bicarbonate. And now I'm left with moles of sodium bicarbonate at the top. Basically, I'm going to make another proportion to switch from moles of sodium bicarbonate to moles of sodium carbonate. I use the mole ratio in order to do that. So in my equation, the coefficient in front of sodium bicarbonate is 2. So I'm going to write that on the bottom because it's on the top here in the middle, and I want to cross it out, so it needs to be diagonal from each other. My coefficient in front of sodium carbonate is 1, so I put that on top. And so here I can see that my moles of sodium bicarbonate are going to cancel. And then I'm left, oops, I forgot my units here, and I'm left with moles of sodium carbonate. So now if I multiply 52 times 1, and I divide it by 84.01 times 2, then I will be able to figure out how many moles of sodium carbonate I will get from this reaction. All right, let's see how this turns out. Okay, so when I perform this calculation, so basically in your calculator you would have to punch in 52 divided by, open parentheses, 84.01 times 2, close parentheses, and then your equal sign, and you would end up with 0.31 moles of sodium carbonate. So that's how many moles you would end up with. The problem is that I don't have a scale that measures moles. I only have a scale that measures in grams. So I would have to take this number, 0.31 moles of sodium carbonate, and change it to grams so that after I run my reaction, I can weigh it again and see if my prediction was correct. So I'm going to take 0.31 moles. Let me just erase this. All right, so I'm starting with 0.31 moles of sodium carbonate, and I need to change it to grams. I know that 1 mole of any substance is equal to the molar mass of that substance. So I have to calculate the molar mass of sodium carbonate. So I have 2 sodiums, which equal 2 times 22.99. And I have 1 carbon, which is equal to 12.01. And I have 3 oxygens, which is equal to 3 times 16. And when I add all of this together, I get 105.99 grams. This is the mass of 1 mole of sodium carbonate. So I'm going to write this at the top. And moles of sodium carbonate gets canceled. And now to find my answer, to figure out how much 0.31 moles of sodium carbonate weighs, I'm going to multiply 0.31 times 105.99, and when I do, I get the answer of 31.8 grams of sodium carbonate. So what in the world does all of this mean here? We've done a lot of calculations, and let's just go back and regroup. My equation says that 2 moles of baking soda, 2 moles of sodium bicarbonate will produce 1 mole of sodium carbonate plus carbon dioxide plus water. The problem is I don't have 2 moles of sodium bicarbonate. I had less than that, less than 2 moles. I only had 52 grams of it. And so what we figured out is that if I start off with 52 grams of baking soda, that I could create 0.31 moles or 31.8 grams of sodium carbonate. Now remember, you might be thinking like, well, if you started with 52 grams of baking soda, why can't you make 21 grams or why isn't it half that amount? Because remember, in a chemical equation, you're not looking at mass here. You're looking at quantities. You're looking at moles. And grams and moles are not the same. The mole is a quantity, gram is a mass, and mass is going to change based upon the combination of atoms that you have in a compound. So what we're going to do here then is I'm going to take my 52 grams of baking soda. I'm going to go ahead and put it into the oven and take it out, let it cool, and see how much is left after I decompose it for about 30 minutes. So while that's going on, you guys should go ahead and answer problem number 9. And under number 10, you should write down what our theoretical yield was. The theoretical yield is how much product, how much sodium carbonate we expect to create when we decompose my 52 grams of baking soda. Okay, so here is my 52 grams of baking soda on my dish, and there is my 400-degree Fahrenheit oven, and I'm going to put it in for about 30 minutes.